Okay guys, I have a new idea. Let me know in the comments what you think. First, a small explanation about lithium batteries. If you read the information from the manufacturer of these kind of batteries, you can read that these batteries have a maximum voltage, a storage voltage and a minimum voltage. Well, the storage voltage is, for example, if you have an electric bicycle and you store the battery for about a half year, let's say about a half year, and you store it with 3.6 volts, the capacity of the battery will maintain the longest time. If you first charge it all the way up into the blue area, about 4.2 volts per battery or 100%, then you will reach the blue area. That means that if you store the charged battery for months and you don't use it, your capacity of the battery will decrease. And that's also if you discharge the battery for about 2.8 volts, it's also no good. If you go under the 2.8 volts, so if you discharge the battery and you reach a voltage that's lower than 2.8 volts, you will destroy this battery. That's also for charging. If you charge the battery for more than 4.2 volts, you will also destroy this battery. So that's about a short explanation about lithium batteries. So if you put these batteries in series, because what can you do with 3.6 volts, 4.2 volts? Well, what kind of equipment can you connect on one of these batteries? Almost nothing. So yeah, you can put these batteries in series to decrease the voltage for about let's say 12 volts or 13.8 volts. That's better to use. So what a lot of batteries do is they will put these batteries in series to reach the desired voltage, and then they have a lot of equipment to monitor every single cell uh, so that this will be maintained. So you need, if you put these batteries in series, you need a battery management system. That's quite complex. Yeah. Also, these batteries. Let me first show you what I meant, what I've made. This is a modular unit to bring 8 of these batteries together. So this battery can put right into this zip, and then you have 8 batteries together. Let's say all these 8 batteries are like most battery packs in series. Then the voltage difference between these batteries is not the same. So if something touches this from metal, you will have a shortcut and you have a lot of smoke and fire, and hell breaks loose. So you don't want that. That's with this unit not possible, because every battery has no difference in voltage. All the negatives are together and also all the positives all are together. So no danger for shortcuts here. Um, yeah, well, so you have 8 times the capacity of only one cell, because you have 8 cells together. Okay, you have one big cell, but still with the voltage problem, because what can you do with only 3.6 volts or 4.2 volts? What can you do? What can you connect? There's almost nothing that maintains this voltage. So you want to bring the voltage higher. You can do that with a boost converter, like this one. This is a boost converter. The input is a minimum 1.5 volt, and the output, you can adjust the output voltage to, let's say, 13.8 volts. Yeah, that's quite nice, but you can see this is not very big. So the current that you draw in from this module is not so big. So what can you connect? Almost nothing. Well, you need a bigger boost converter, like this one. Now this model has an input and an output, and also a minimum input voltage. And this minimum input voltage is higher originally than this 4.2 volts, or a minimum of 2.8 volts. So yeah, I made a modification on this unit, because this is the brain of the unit, and this brain wants to see 13.8 volts. So there is a small boost converter for this unit, and that boost converter for this unit has a minimum voltage of let's say 6 volts. So that's too high. So this one, the small one, has a minimum input voltage of 1.5 volts. So what I did, I disabled the original boost converter for its processor, this circuit. I disabled it, I removed it, and instead of that small boost or buck converter for this circuit, I used this one. So now the input voltage has a minimum of 1.5 volt because of this modification. And you can draw a lot of current from this. Only, well, the problem is when you draw a current from here, the current from the input will be much higher because the voltage is lower from this battery. So you can put 8 batteries together, but even 8 batteries will not be enough for maintaining this current. So I made a few of these modules, and they will be all hooked together. So it will not be in series connections, but it will be parallel connected. All of these modules, 48 batteries, parallel connected. So the voltage is not going up, the voltage will stay the same as only one cell. But the current, the maximum current that you can draw from this, will be much higher. So this is my idea. No BMS is needed. You have no danger for shortcuts. Every cell has its own fuse. That's the word I was looking for. Every cell has its own fuse. This is a small wire that will burn if there is a shortcut. So every cell has its own fuse, just like Tesla battery packs. So that's the idea. No danger, no BMS needed. A lot of current, you can draw a lot of current. Now this modified boost converter, and this is the point where you can get every voltage you want. For example, 13.8 for or 12 volt or whatever. You can adjust the voltage on whatever voltage you like. So this unit has to be charged. Now you can use a buck converter for this. This is a quite big, heavy buck converter. The maximum input for a buck converter will say that you have a higher voltage, and he's converting it to a lower voltage. So if you have, for example, 24 volts, you can put the 24 volts here. It will make 4.2 volts here with you can adjust the maximum current. So yeah, this is for the charging. So if this is all in a box, and this is the charging module, and this is the consuming module, and this is all in one box, I think I have a quite nice power pack. What do you think?